Aboard. Uh, Today we're going to talk about architectural drawings, the foundation, design, and construction. So really, I want to give also just take a moment to give credit to Tanya for all the work she's done in the past for FNNBOA. So thank you very much, Tanya, for all your support and your friendship. Very much appreciated. But to move on, the quality of construction drawings is crucial for the success of any project. Poor drawings can lead to costly delays, financial losses, and certainly potential safety concerns. Well, architectural plans are essential for project success and for cost management and also for maintaining, hopefully, better construction timelines. So let's take a little bit of what is architectural drawings. Well, understanding building construction is essential for professionals in the industry to interpret and visualize the construction prints accurately. Construction drawings are graphic tools that communicate what needs to be built or made, what materials are needed, and what specifications are required. This presentation begins with an overview of the language of architecture and construction drawings and continues through a series of common plans primarily for a small building construction project. So some of the key points on our agenda: the introduction to architectural drawings, the various types of architectural drawings, some key elements and symbols in the architectural drawings, and about the process of creating an architectural drawing set, and also the significance and application to Indigenous housing and communities. So first off, if we take a look at the definition, they're graphical representations of building designs that communicate spatial relationship through dimensions and certainly through construction details. Well, it's the universal language for architects, engineers, contractors, and certainly for their clients, supporting decisions from concept through construction, enabling compliance and documenting the project life cycle. So that's briefly what architectural drawings is all about. But certainly there's a lot more to them. We take a look at drawings in architecture. We talk about conceptualization, starting with an idea or a concept, and turning that abstract idea into what they call visuals through creative exploration, and coming through with some concepts and testing that design. Also, we talk about the word coordination, providing a shared language for architects, engineers, and builders, aligning the intent, structure, and safety. And certainly about the documentation portion. So the drawings are record project decisions for construction, for future changes, and long-term references or archiving. So again, architectural drawings serve as graphical representation of building designs, conveying spatial relationships, dimensions, and construction details. They function as a universal language. These drawings support decision-making from conception through construction, facilitating communication, legal compliance, and documentation right through, like it indicates, the long-term project life cycle. Well, let's talk about some of the types of architectural drawings. And I will be getting into a little more detail as we go through towards the latter part of the presentation. But when we take a look at it, there's what they call the pre-design or the schematic, the exploring the idea stage, we'll call it. The second one is the design development stage, where the design is developed and refined. Once it's agreed upon with the client, the architect will get down into what they call the actual construction drawings and working out all those details. One of the final stages is certainly a professional set of architectural working drawings. So when we take a look at this next slide here, we're going to talk a little bit about plans and elevations. They're common construction drawing elements. Floor plans provide a bird's eye view outlining spatial layout and footprint essential for arranging the rooms and circulation paths, and also for planning adjacency and flow. Suction cuts, on the other side, the right-hand side, we can see are vertical cuts that reveal floor-to-floor relationships, structure, and system for coordination and evaluation. In other words, a lot of what is shown in that section cut over to the right-hand side, we refer to that as a wall section. And it's basically indicating all the different construction components, elements, the materials, and in some cases, even dimensions of some of those materials. So for example, footing sizes, the depth of the footings, the height of walls, pitch of the roof, and so on. When we take a look at the ones in the middle here, or the one in the middle rather, the elevation or elevations is a straight on facade view, in this case a front view, that communicates the exterior form where the openings are, such as the windows and doors, and the material characteristics, in this case, such as it has pressure treated wood posts, vinyl siding, and asphalt shingles on the roof. And we can see that it also has a roof vent. So again, these are just some, we'll call it illustrations of some potential of what an architect or an engineer in this case has developed as part of their drawing package. Drawings and documents. Well, drawings and documents, the average number of drawings in a typical residential construction document set highlight the need for precision through coordination. I find in many cases it's generally less than 10. In fact, or hopefully more than 10, we'll get into the actual detail of why I say more than 10 later. So like I say, average set of drawings I see is usually 4 or 5 drawings to a set of drawings for let's say, a residential build project. Well, we want to also drill down to detailed drawings to find the joints, the connections, the finishes, the construction documents compiled on the drawings, specifications, and the schedules as contractual and coordination deliverables. Certainly, accuracy prevents costly errors and supports building code compliance. So again, I'm going to focus on some of those things a little bit later. Here's an example for, in this case, a presentation of a rendering of one of the FNNBOA's housing projects. So in this particular case, what's a rendering? What do? They enhance the visual through color, texture, and some 3D lighting. They're translating this housing design to basically with the intent of offering a compelling view of the proposed building or space. So for example, in the lower picture, and by the way, this is done by, these renderings are from Solo Architecture, one of our projects that we did with the FNNBOA funding and money to develop a set of architectural drawings for 1, 2, and 3 and 4 bedroom housing, and in one case, a duplex unit. So we can see kind of a interior rendering of a kitchen and dining space. Along the right-hand side are a series of bedrooms, the bathroom, and certainly mechanical room. But why do they matter? We take a look at them to influence decision and funding by making these abstract ideas feel a little bit more realistic, helping to support approvals and lining up stakeholders, and certainly they can be used for marketing. Next, I want to talk a little bit about the architectural drawing symbols. I like to call it the language of architecture. It's based on a series of what we call various types of lines, various types of symbols. Certainly, we talk about dimensions and notations, so notes on the actual drawings. And certainly, we look at things called the scale of the drawing. So again, I'm going to run through the next couple of slides of just giving you a little bit of background of what is required as the language portion of this. So for example, I mentioned different types of lines. So we can see On the left-hand column here, property lines, contour lines as some examples. Another one that looks like a whole bunch of squiggles, which is the bad insulation. So there are various types of line works and line weights that are used when we create architectural drawings. Over to the right-hand side are some examples of some material symbols. So there's a whole different set of symbols that are used for various types of materials. So we can see, for example, the aluminum, the brick. The brick is basically a 45-degree line in between two lines, indicating by probably the thickness, usually 3.5 to 4 inches thickness of brick on a set of drawings. What's a CMU? Well, that's an abbreviation for concrete masonry unit. In other words, something like a concrete block. Concrete below it is really, it doesn't show too clear in this particular image, but really between that wall, we'll call it wall thickness, there's a series of little dots that represent pebbles in the concrete. And so you can see here, looking at insulation bats, again, we see those squiggle lines. So these are all used as different material symbols on a set of drawings. If we take a look at wood blocking, solid wood members, over on the far right-hand side, we see it as basically a shape with an X through it. And wood finish, the very bottom one there, again, another example. Looks like it has just some free, we'll call it free drawn lines in between the materials, which indicates that's a finished wood. We'll call it designation in that particular case. So again, these are a few of the examples. There's many, many more. Just to kind of give you a quick overview of what is comprised in architectural drawings, what to see, what to expect. Moving over to the left-hand side here, on this particular side, we see sample materials and symbols. So as an example, we see a wall. This is looking at it, and we'll call it bird's eye or plan view, looking at brick and insulation in a window in the very, very top portion here, if I can point to it here. Again, we see more windows. In this case, we have what they call tags, indicating this is window type B. We'll talk about that. We talk about schedules. There could be different types of windows that are scheduled and tagged with usually some type of either letter or number in which goes back to a legend in the set of drawings. Standard exterior door, okay. A standard exterior double door, and a standard interior door in a folding door in a closet. So again, some various materials and symbols. And again, these are just some examples to try and explain sort of the language of architectural drawings. Over to the right-hand side are what I call the section symbols. So for example, where do we find a particular detail on a drawing? So we can find it located on a sheet, and a detail is found on sheet. So again, we see drawing symbols, title symbols. If there's multiple locations, over to the far right-hand upper corner. Okay. Door symbols. I mentioned, for example, that window symbol tag. So we see in this case, there's an A as opposed to over here was a B. Room identification, so the room title. Not that we need to necessarily give it a title such as a bedroom. It could just simply be space number 1, 2, or 3, or so on. We typically will use north arrow indicating which way in plan view or even in elevation view that we're actually looking at that particular, according to what we would use as a compass, I guess, reference point. And we can see here in the lower right, a little storage shed. And we see these examples of the section cuts through this particular storage shed. What we're looking at is a plan view with a door, a couple of windows, and we can see the outer materials indicates that it's brick. And inside we see a wood stud, wood frame wall with bad insulation. So again, we get to know a little bit about the language of architecture and architectural drawings. So in other words, we need to know and understand how to not just look at the drawings, but understand how to read the drawings, getting to know them a little bit better. Sections and details, again, over to the left-hand side. We can see here some standard details we looked at a little earlier. Elevation, symbols. So for example, we see below this line, there's a footing, which is those hidden or what we call dashed lines. You get an idea of there's some type of siding with a door and a window in a roof in a section cut. And then something more on the commercial side of things. We see this would be more of a commercial building with an open web steel joist, a drop down ceiling, okay, suspended ceiling. There's a window over here, and we can see that part of this masonry wall goes above this, we'll call it flat roof plane. And to me, when I read this, I look at there's rigid insulation with probably some type of ballasted roof membrane on top of that particular section detail. Again, when we talk about dimensions are critical because we can use them, especially in the, we'll call it the layout and framing stages, early construction stages. Where are the major cuts and jogs? Where are the windows and doors? What's the size of the room and space? So all these are needed to basically properly lay out every room and space or even the building itself so it exactly fits to those particular dimensions. So again, there's a lot of information on architectural drawings. And it's not just to pick on architectural drawings. Certainly engineering drawings are probably very, very much similar. Moving on, I'm talking about abbreviations. We saw earlier, for example, maybe a reference to a term. So in other words, rather than having to write everything out, the use of abbreviations is often used on architectural drawings. So for example, I was teaching a course last week on building code and they said, what's OC? Well, that's on center. So when we talk about things such as, we'll call it joists or wall studs or things like that, we're talking about OC. Or something like NIC, that means not in contract. Or MO, masonry opening. Or we could jump up and we could talk about other things here. So for example, WD, representing wood, or RO, a rough opening. So a framer's rough opening before, let's say, a door or window is going to be placed in. So again, the language of architecture. Over to the right-hand side is what is a surveyor's site plan. And this is of a subdivision where there was a series of houses that are going to be built. And we're going to focus on, for example, we see this, what's called River Downs Avenue. All of this is surveyed property. So for example, we have the rear dimension of the property. This is on a curvature. So kind of an arc here. This is more straight frontage. Again, these lots tend to be in this particular left-hand side a little more, we'll call it wedge-shaped. So the front is smaller than the rear portion, the rear yard area. There's a storm water retention pond for all the storm waters run off to the pond here. And we have a road here, an FH. And if we take a look at FH, if we go down to what they call the drawing legend, it's a fire hydrant or an SL. So again, we see all these different things here that are designated by a legend indicating exactly what these are in this particular, we'll call it site survey plan. What we see here is within the property, we see a set of boundaries. And this is when we talk about municipalities, we get into what they call setbacks. So for example, there needs to be a certain amount of space left between the property and the edge before a house can be built from here over to this particular setback here. So in other words, there needs to be spatial separation between building units to reduce the spread of fire. So and this is part of zoning and zoning application when we talk about, in this case, these are residential building lots. So just to kind of give you a little bit of background, by the way, these These ones in the oval 538 are the municipal addresses. So this would be 538 River Downs, 540 River Downs, 542 River Downs. So again, this is just a partial plan of a surveyor's site layout or site plan. Okay, so in this particular case, my son was going to build a house on this property. So here's my drawing over to the left-hand side of the proposed house. And we were looking at that property before here, 540. And I have the property line shown here and the setbacks. And how did I fit the house onto the property within the setback boundaries? So we can see here in this particular case, a sample site plan. And then I was required to, on the architectural drawings, we talk about roof drainage is through roof scuppers. By the way, this was going to be a kind of a low slope, virtually flat roof house. There's a set of stairs that was going to go down to the basement. So there was a stairwell going down to the basement. You could access it from inside, but he wanted an office studio in the basement also. So this was the reason for this particular drawing in detail. Then I had to talk about the zoning regulations. So I had to indicate the information for get the building permit, saying, okay, the front yard setback was X amount, the rear yard setback, okay, coming from the rear to the back of the house. So the house had to fall within those boundaries, couldn't go within, let's say, outside of the boundaries. Otherwise, they would basically refuse the drawings and ask for a resubmission to make sure that it complied with the zoning requirements. This is an aerial view of this particular property. So again, this aerial site survey. So these two houses are built, and this was going to be the building lot for this particular house to go onto this property. So again, a very, I guess quite a bit of different information that the architect or the architectural designer deals with, or in some cases, if it was an engineer, that the engineer is going to deal with. So I just wanted to talk about this. So this is a base map. It was based on an aerial photograph taken of the particular county in the area that we live in to basically reflect not just site surveys, but in this case, even an aerial survey that matches up with the surveyor's drawings. Okay, so let's talk a little bit about some other considerations. I mentioned earlier, I often see drawings that seem to be, I guess I'll use the word lacking, not enough information to really build from. So I guess when we talk about architectural drawings, and we'll call it even later on about the issue about hiring an architect to do drawings, the architect's going to obviously charge you a lot more for drawings, and certainly is going to provide a lot more drawing content than typically what I see that comes from a very simple basic set of drawings, such as 3 or 4 sheets of drawings, maybe 5 or 6 sheets of drawings. So what I was trying to depict here is drawings. So some other things we need to think about. And I'll come back to why we need to think about this. So you'll see below drawings, we could have schedules, room finishes. There are drawings such as structural, electrical, plumbing, and heating or HVAC, heating, ventilating, and air conditioning. So I just kind of made it a simple set of drawings here for a floor plan. Certainly we'd have a site plan, a schedule, elevations, sections, and details. I got 1, 2, 3, 4, 5 drawings for architectural. If I put the site plan in with the civil and the grading and the details for civil, now we have 8 drawings. But what about structural, the foundation, the schedules for the foundation and for the framing, the roof framing as an example, or floor framing in the sections and details? And what about the HVAC? And I put HVAC with the mechanical side of things. Okay, so heating and need to go back a minute. Sorry about that. Heating, floor plans, diagrams, and details. And what about electrical? Altogether, we could end up with something in the range of easily 10, 15, or in some cases, maybe even 20 drawings for a set of, we'll call it even house plans. So I guess my point being is, with a lack of we'll call it drawings, sometimes a lot of decisions are simply left up to the contractor, the builder. And we find out in some cases, things don't work out always so well because a lot of that information is sort of a judgment thing of, oh, that's the way we did it in the past. That's the way we do things. But I think that's part of where we kind of fail to realize that all these things, the architectural, the civil, okay, the infrastructure, the structural, the plumbing and the heating, electrical, all need to be coordinated together. All above, you'll notice I depicted 4 pictures. Retaining walls that fail, a beam on a 2x4, inadequate structural, notching of roof framing, or in this case, floor framing members. Again, this is a structural concern, but also, hey, the plumber and the heating contractor in this particular case has to deal with, I had no drawings, so I got to notch it out. Well, what we see here is now a structural problem. How about in this particular case, we have a jacuzzi tub, nice vanity sink, and we have an electrical outlet. Not supposed to be there. So all of these depict problems that can occur, probably many, many more problems I have on file of what happens when there's a lack of drawings and lack of detail and lack of information. So again, I'm not trying to criticize, but when we shortchange things and we accept just a simple set of drawings, sometimes things like this, these problems will happen and occur. So again, how do we reduce them? We need more information. We need completeness in a set of architectural drawings. But what about specifications? Well, drawings generally provide the graphic location. We can see of the various elements such as the location of columns, their dimensions, materials such as concrete or was it steel. However, the quality of the material, their properties such as the strength of concrete, and the test methods required to confirm that it actually does meet code is proper. It's a proper, we'll call it strength of concrete was being used for that particular project. Often we find those things are missing from the construction, the actual construction drawings. This information is what we call the written document, and it's often identified by the word specifications. So what about specifications? To me, from my architectural background, the two go hand in hand, sort of the left hand and the right hand. They need to work together. Next, I'm going to run through what I use as my architectural drawing process. In this particular case, we were doing a local branch library, and I call it the library study. I'm going to go through 15 different, we'll call it little illustrations here, of our process of dealing with an architectural drawing. So we first off look at the site. So we do the site review. So over in the corner here, this very first, we'll call it illustration, this was the building site. We can see there's some different profiles of different grades here. It's on a corner of Mulberry and London Lane. Then we take a look at what we call the circulation study. So how would people access the site? Seems pretty straightforward maybe for a house, but when we talk about maybe something a little bit more complex than just a house, we get into what we call circulation studies. Then we take a closer look at the property and we analyze what we call the hard facts. What's on the property? So we can see there's different grades. Up in the upper left corner, there is some rocks that we have to deal with. There's a rock outcropping over here. There's some trees, and we see the grades kind of fall off going towards the bottom of this particular site. We also take a look at step number 4, I like to call it, the climatic data. So where is this library going to be built? So, for example, is it in my area, Windsor, or is it in Ottawa? Is it in Val-d'Or? Is it in Winnipeg? What are some of the climatic conditions that we have to look at that will impact this particular building? Because that's going to impact not just things such as what is shown here, the solar path, but what views we have, also what winds we have to take into account. So what are the summer winds and the winter winds? These all come into play when an architect basically studies a site. Well, the other thing that we need beyond just the site is we need the criteria from the client. How are we going to solve their particular building requirements? So we have what we call a problem statement. How are we going to solve the problems? What are some of the goals? So things such as it should have a children's reading area, okay? It needs a work counter. We also wanted to have a community room in this particular library, or they wanted to have a particular room. So we can see here, goal setting, program review, comparison of areas. So we kind of sketch out and kind of put these, we'll call it blocks of space together. And it's like a jigsaw puzzle, trying to fit them all together. Then we get into what we call functional diagramming. So for example, when you come in, you go through the lobby, there's going to be your basically reception area. Over to the right, the left-hand side was going to be a community room. And then there's going to be breakout areas for children's reading, outside view, a reading area for adults, things like that. So all these things had to take into account sort of the flow, the function of space collectively, not just a series of little rectangular boxes like in number 6. This is what's called bubble diagramming, number 7. And then number 8, we start taking those larger chunks and we take a look at different alternatives. So we can see we have 4 or 5 different possibilities of how this layout could be put together into a functional diagram in which we create some suggestions of space. We talk to our clients about these things, about what do you think? Certainly we as the architectural side have our opinion, but certainly the client's point of view is always important to be considered. Next, we get into what we call a schematic arrangement. So for example, based on the previous, they've come up and we've decided to go with a specific sort of, we'll call it schematic arrangement. Again, we haven't really refined the space in a lot of detail, and that's schematic step number 9. But by step number 10, we started to break it down and define and develop and refine the workspace. In number 11, we come up with some conceptual ideas of what this building will look like. So for example, the 2 lower illustrations, sort of the, we'll call it elevations. The top giving sort of a section, we can see kind of a high slope roof going down to a lower, so kind of a shed style building with sort of a flat roof in between. Again, when we take a look at who else is involved, we have to take a look at what about the structural system? We got some large spans, we got some shorter spans. So we have to take a look, what can span these particular, we'll call it distances. So again, we have to take a look at working with our structural engineer, or maybe even thinking about people in step 13, such as the mechanical, the plumbing and the electrical. How do these things all fit together into this building? And then eventually, hopefully refining it into what we call the circulation patterns. So for example, people coming in from the street, upper part in this number 14 diagram, in the parking area and coming in, so we'll call it sort of the back side of the building. And then finally, we come up with, and it's just a partial indication of what we call the preliminary drawings. So again, we've gone through 15 steps before we've even created the construction working drawings. These are the forming the architectural drawing process that we're taught in design school and architecture, of going through a process to refine a design. And certainly once we create this preliminary drawing, we're going to go back to the client and get their approval or comments or feedback, and perhaps we might have to make some changes. Next, I'm going to talk about design and coordination flow. So we're going to share these drawings with our client, distribute the architectural sets of structural, mechanical, electrical, or any specialty consultant. So for example, some projects we had kitchen consultants because there was a large, we'll call it commercial kitchen involved. We're going to review the input, collect the markups, get the feedback, look about requests for information. Perhaps we need more information about the heating equipment or the cooking equipment or certain particular equipment that might have to go into this particular design. We talk about coordination notes. And when we talk about coordination notes, what I'm really talking about is, well, we're focusing on the architect's point of view, but what about the structural engineer's point of view? You know, what about the plumbing and heating, those engineering professionals that have to be basically review their input and see if things will work and we can put them together. And you can see in step number 3, we call it the integration of revisions. So coordinate and update to reduce any conflicts. Remember that heating pipe that went through one of the structural framing walls in the earlier picture? How we can reduce those conflicts, but those things happen if things are not managed properly right from the beginning. So we want to improve the constructability, certainly across the various disciplines that are involved when we talk about designing any building, whether it be a house or a larger project. And then eventually we publish and track. We use what we call cloud collaboration when we talk about different versions, in comments, and approval sets. So eventually we're going from 60% and hopefully upwards towards that 95 percentile, and hopefully at the end, 100%. Certainly of coordination on a particular project. Well, we also have to think about, certainly I mentioned earlier, the client's review, gather the goals, the preferences, make sure everything is in the scope, and if there's any changes or change of mind, these things all align with the drawings and with the intent of the client. We also have to think about the authority approval. So for example, going back to my son's house, we had to go through a building permit process. So these drawings had to be submitted in completeness, appropriately designed by a design professional, reviewed, and of course they review it not just for code compliance, but also in this particular case for zoning approval to make sure that that building wasn't going to be going outside of, we'll call it that zoning building box of those setback dimensions that were required. It also, for example, one thing I didn't really touch on is it also talks about land coverage. What percentage of land can be covered by that particular building? Certainly secondary buildings such as a shed or we'll call it a patio, those are okay. But the actual building, main building itself had to be within a certain percentage of maximum limit of coverage on that particular lot. We also take a look at construction feedback. So often we would go to a local builder that we've known to try and get some feedback. So validate the feasibility. Is our estimated cost going to be within a reasonable approach of what a builder would think it would cost that particular builder to build? So we kind of get some preliminary cost estimates to make sure that it's falling within the, we'll call it the budget that the client had projected as part of their cost to build this. And also taking a look at the detail, certainly the construction feedback, we take a look at other experts looking at these drawings to make sure that there's nothing that's going to be problem down the road. And certainly if there is, we're going to revise and keep track of those changes. So again, implement updates and manage versions and approvals through project software. So obviously, until the drawings are officially stamped by an architect or an engineer, there could be subject to change, and you want to know at what point those drawings are finalized. A couple of things, just kind of as a off chance. I was brought up with hand drawing. Initially, I did hand drawing. We'll call it drawing on the old drafting table with a parallel and all that different drafting equipment. And certainly, it creates creative exploration, rapid conceptual sketches, fosters a direct connection between designer and idea, and ideal for early stages of ideation. So what are some of the Disadvantages. So it lacks precision for detailed plans. So things that are repetitive, I can do very easily with CAD or, CAD as opposed to a hand drawing. So again, I need not just a pencil or a pen or some type of, we'll call it modification, eraser to change things, as opposed to digital drafting. It's highly accurate, easy to modify. It supports 3D visualization. So we saw some visualization of a 3D rendering, both inside and outside of a building earlier. And certainly some of the disadvantages, well, certainly there's a learning curve to it. So it can limit some creative spontaneity. So for example, I would say hand drawing tends to be more artistic in fashion as opposed to, we'll call it more, a house is a house is a house, and it's pretty easy to come up with digital drafting with, we'll call it a CAD-based drawing system. BIM, we kind of skipped over. BIM adds data integration and life cycle management. So I'm going to be talking a little bit more about BIM in the future, but building information modeling. So for example, we can also put a lot of data into a set of drawings. So for example, who sits at desk number 1 in an office? By the way, what's their phone number? What's their address? We can get into all that personal information or not. But we could also get into a lot of other detail or data that can be collected to that particular, we'll call it person who sits at that particular desk. So again, BIM information also, we can model the building to see if it'll structurally fail because there's software out there when we deal with a building information modeling that is sort of smart design software. Let's take a look at some practical applications, some situations where we've had some indigenous architects do some really nice design, so some modern architectural applications. So in Delaney, Northwest Territory, again, a different type of house design. So again, this software visualization. Nunavut, private housing unit. Nunavut social housing unit. West Coast building standards, so some practical building from, we'll call it native materials from the area when it comes to wood for the West Coast building standard. The Bunnaby, Manitoba, again, this is a multi-generational house. So the one in the middle, we have a first, second, and a third floor. So we have 3 different generations living in this particular house, or potentially that could be the situation. Of course, the other one is RTMs, ready to move, factory built housing. And again, in talking to some of the people that I've been doing a lot of code training on National Building Code, and talking to various indigenous communities about the National Building Code, we often talk about the RTMs, about some of the issues with RTMs. Maybe good design, good plans, but also issues in the actual movement of buildings. But certainly modern architecture, I guess RTMs are also part of the picture. Construction management and project management. Architectural drawings guide construction, improve safety, coordination, support scheduling, budgeting, real-time tracking against planned deliverables. So again, guiding construction, they provide clear instructions for builders, ensuring structures are built to specifications and minimizing errors. So again, architectural drawings to me are important, the quality of those drawings. How about safety compliance? So incorporate safety standards, helping teams adhere to regulations and avoid hazard. Scheduling, they help define project timelines, allow for accurate scheduling of tasks and milestones. They facilitate communication, collaboration, not just among contractors and subcontractors, but also the stakeholders. Like I say, part of the architectural team is just always just the architect. In some cases, we have to reach out to a structural engineer or mechanical engineer or an electrical engineer, especially when we get into more complex projects, not so much for residential. Also for budgeting, plans enable detailed cost estimates. The more information on a drawing that an estimator can look at and understand, the better chance of coming up with a more accurate cost estimate. So again, reducing unexpected expenses. We often hear of What about an extra? An extra for this, an extra for that? Changes means extras, and it just means money for the builder. And certainly we can do what's called real-time tracking. Project management systems allow for monitoring progress and adjusting plans as needed. So how about on the legal and regulatory side? So drawing setup support permits, approvals, and liability. So drawing support building permits, zoning if you have zoning approvals, and legal documentation requiring strict adherence to local codes and standards. To me, the minimum legally acceptable building standard is following at least the National Building Code. Likewise, architects and engineers design, so it will meet either the National Building Code or in some cases, a provincial code. Accurate compliant plans reduce disputes, improve safety, and uphold sustainability. Digital archives enable future renovations and strengthen liability protection. So how about some future trends in architecture? Well, VR, virtual reality, okay, and AR let teams experience space at true scale, improving clarity and confidence before construction. We can go through faster design iteration. 3D modeling accelerates exploring of options and enabling rapid changes and fewer late stage surprises. In BIM, building information, and VR, virtual reality, over the next decade, BIM, integrated virtual reality, is expected to reshape drawing workflows and stakeholder engagements. I taught in the college system for 26 years. All of our students, what they could always fall back on is their CAD knowledge and training. They all got jobs because of basically computer-aided design. Not all of them went on to be architects, or even in some cases engineers, or even we'll call it construction managers. So again, certainly having the background in architecture certainly helps support them develop their job skills for work. Conclusion, yes, architectural drawings matter. So we have a shared design language when we take a look at drawing bridge creativity and technical precision. We can see I've kind of brought you through from a sort of a design, we'll call it preliminaries, into, we'll call it the actual finished construction drawing. I also touched on the various types and symbols, the language of architecture, a little bit of understanding drawing sets, conventions, and symbol improves clarity and accuracy. So again, we can see another architectural symbol illustration here about the building code. So in collaboration and compliance, we need to build to building code, but we also have to have drawings and designs that meet building code. And certainly with the digital evolution, there are modern tools out there today that extend drawing tradition from, we'll call it a pencil and paper, and now on basically computer-generated drawings, both 2D, 3D, and very illustrative. In this particular last one, you'll see off to the side, there's a bunch of information that's attached to this particular drawing. So again, there's a lot of data and information that can be shared amongst not just trades, but also amongst the clients for data collection and future, we'll call it, use. So do you need to know more? If you want to, you can join us at the FNNBOA's FN Learning Hub, fnlearninghub.ca. There's no charge for our courses so far. So we offer free education and training courses online. I say it simply look at what we offer. You can put in your request to me, C. Lawrence, I just leave off the ON, at mnsi.net, or contact FNNBOA, and they eventually will get to me. I operate as an education consultant for FNNBOA. Like I mentioned, I'm a retired college professor. What would you get if you sign up for one of our courses? Well, we need to know who you are, your email. You're going to receive a username and a password, and of course, you can jump in and start your course. So again, here's sort of a depiction of the, we'll call it the home page or web page for the Learning Hub. And here's an example of just jumping into one of the courses, FN First Nation 107, print reading for building construction. So again, if you're of interest, please feel free to contact me. Again, I want to thank you. you can either contact me at my email here or through FNNBOA, info@fnnboa.ca. And again, I work on behalf of First Nation National Building Officers, FNNBOA. So again, we want to help build better housing. And I'm going to leave it at that part. So if you have any questions, feel free to let me know.
So Claude, I have John who has he's commented, just recently I received a telephone call from one of First Nations asking about whether art drawings needed to include rough-in for radon gas. The answer is yes, but I was more surprised that this was part of the conversation.
The answer is yes.
Yes.
Both the national building codes and the provincial building codes require radon rough-in. This has been in the last 2 cycles of the building code. Certainly, radon is an important health concern topic. So I would say yes, radon in all new construction. The problem is if we take a look at existing homes, the only way we can really we'll say go back is to actually do the physical testing in a house to see if radon readings are high enough, over 200 becquerels per cubic meter. If it's higher than that, it's time to really get serious about radon, not just in that house and possibly even the community. So yeah, radon rough-ins are required by new houses, period.
And that cost is only at about $400 to $600. The challenge is if you don't do the rough-in, it could be $3,000 to $5,000.
That's John. Yeah, yes, that is correct.
Yeah.
Again, just recently being up in Val-d'Or, Quebec, with the Cree Nations, talking to them, I found out their communities are becoming quite well aware of the issue of radon, and yes, they do get some high readings in some of their communities. So even at best, we'll call it at least, they're putting test pucks into all homes just to try and get a feel for the radon levels in their particular community.
Yeah. Yeah. All right. Thanks, everybody.
Oh,
I have to dash for another call.
Claude, Lisa has asked, typically do technologists provide hard copies of the drawings produced for the client, or is it up to the client to print them for themselves, or does it depend on the signed contract between the technologist and the client? What service is provided?
I would say a good thank you for the question, Lisa. Actually, that's a very good point. Typically, the drawings are owned by the designer. The issue of printing depends of what was agreed upon. We'll call it the agreement or contract if there was one. And it could go either way. If drawings were included, typically I would indicate that I'm going to provide them with 3 sets of drawings. In some cases, it might be simply no. Can we do our own printing? And the answer to that would be yes, if that's what they agreed upon. So it can go either way. It really depends on getting back to what was the agreement with your client. But good question, because you don't know until, I guess, you face that issue. Yes. Any other questions out there? Maybe one closing thought I'll let you think about. Certainly, Lisa raised the question about a technician versus an architect. There depends. So, as an example, in Ontario, in order to do a set of, we'll call it architectural drawings, you must be code certified. So most other provinces, you don't necessarily have to be code certified. You just probably have to be reasonably understanding and knowledgeable about how to do a reasonably good set of drawings. Certainly when we talk about costs, the cost difference typically for a set of house plans through a professional architect could be 5 to 10% of the estimated building costs. So it might be, let's say on a $350,000 project, it could be as high as $35,000. It might be as low as, well, in the ballpark of maybe 2,000 or 3,000 through a technician. So let's say a trained technician, college graduate, doesn't have the architect or engineer stamp, but they're, let's say, a building technologist. So again, a big, huge difference. So it's almost like, a 1% versus 10% when we talk about costs. So again, a lot of costs when I was doing drawings would vary on what I saw on the average amount of time spent per drawing. So for example, if I'm doing 10 drawings and I figure it's going to take me 30, 40 hours per drawing, multiply that times your, we'll call it your hourly rate. Easily it could be in the high range of getting close to $35,000. In some cases, it might be less. So again, just to kind of give you some ballpark ideas, certainly the professional, you have to look at, well, what about errors and omission insurance? The construction tech might not have errors or omission insurance. So what happens if things go wrong with a set of drawings? So I've reviewed some drawings where the beams were not properly sized, they were undersized. So right from the design stage, if they were not done properly and reviewed according to building code, what's the minimum size beam that's required for that particular span, you might end up with a problem, not to blame the builder, but also based on we'll call it the poor or the incorrect sizing of a beam for a house. So again, the mileage will vary. What you get, certainly, do you go with the cheaper version or do you go with something more reliable? So again, I'm not here to just simply promote that architects are the best path. Certainly they're a good path, but certainly there are some good technicians out there that can also do a pretty darn good job at we'll call it at a savings, if you want to take a look at it from that point of view. My biggest issue is when I see a set of drawings that have multiple issues with it, it's either over-designed or under-designed. In the field, think about the builder's perspective. How do I make more money? Is I'm going to do the least bit I have to possible. Or in some cases, maybe even I come back if there are problems. So again, thank you. Any other questions before I kind of finish off? I guess that's a resounding, I don't think so. Again, Tanya, thank you. Thank you, everyone, for your questions and for your participation. Hope you tune in and we'll talk again soon. Bye for now.
Perfect. Take care.
Take care, everybody.